Have you ever just stopped and wondered what everything is actually made of? I mean, really made of. The phone in your hand, the air you're breathing right now? It all comes down to this incredible, invisible dance of tiny, tiny particles. Today, we're going to pull back the curtain on that dance. Welcome to our explainer on chemistry, the science of stuff.
So here's our game plan. We're going to start with the big picture. What even is chemistry? Then we'll zoom way in to meet the absolute star of the show, the atom. We'll take it apart, see how we keep all the different kinds organized, and then the really cool part, how they all link up to create, well, everything.
All right, let's dive right in. We are kicking things off with maybe the biggest question there is. What is everything made of? And you know, this isn't just some dusty old science question. People have been wondering about this for thousands of years. In chemistry, it's our best shot at finding the answer.
So if you want a formal definition, here it is. But a better way to think about chemistry is like it's the ultimate how it's made for the entire universe. It's the science that looks at the most basic ingredients, atoms, molecules, and asks, okay, what are they like? How are they put together? And what in the world happens when you mix them up? It's basically the rule book for all matter.
Now, if we want to understand that rule book, we have to start with the most fundamental character in this whole story, the one thing that everything else is built from. So, let's meet the atom.
And there it is. This is the classic picture you've probably seen 100 times in science class, right? You can see the basic setup right away. You've got this dense little cluster in the middle, that's called the nucleus, and then you have these other particles just zipping around the outside.
So, officially, an atom is the basic unit of all chemical stuff. You've got that dense nucleus smack in the center, and then it's surrounded by what we call an electron cloud. Now, it's not a hard shell or anything. It's more like a blurry region of space where you're most likely to find those electrons. And this simple layout, this is the blueprint for literally everything.
Okay, so now that we've seen the blueprint, let's pop the hood and see what it's actually made of. We're going to take a look inside the atom and meet the tiny particles that give it all of its amazing properties.
This table breaks it down perfectly. So, packed inside that nucleus, you've got two kinds of particles. You have the protons, which have a positive charge, and the neutrons, which, you guessed it, are neutral. They have no charge. Then, whizzing around on the outside, you have the tiny negatively charged electrons. And it's really the attraction and repulsion between these charges that drives all of chemistry.
And this right here is super important. It is all about balance. In a normal, stable atom, the number of negative electrons is exactly the same as the number of positive protons. The charges cancel each other out perfectly, which leaves the atom with no overall charge. It's totally neutral.
Okay, get ready for this, because this fact is wild. The radius of an atom is about 10,000 times bigger than its nucleus. Let me put that in perspective for you. If the nucleus was a marble sitting on the 50-yard line of a football stadium, the electrons would be flying around way out past the nosebleed seats. What does that mean? It means atoms, and by extension, you, me, and everything else, are almost entirely empty space.
So we've got this basic design for an atom, right? But here's the thing, not all atoms are the same. There are lots of different kinds. And lucky for us, scientists came up with an absolutely brilliant way to keep them all organized.
This brings us to the idea of a chemical element. An element is just a pure substance that's made of only one single type of atom. So what makes a carbon atom different from, say, an oxygen atom? Well, it all boils down to one simple thing. How many protons are in the nucleus? That number is like an atom's fingerprint. It's the one thing that defines exactly what it is.
And this beautiful chart right here is the master catalog of every type of atom we know of, the periodic table. Seriously, this is the chemist's ultimate cheat sheet. Every single element is on here, and it's not just a random list. It's organized in this genius way that shows you all sorts of patterns in how they behave.
Let's quickly break down two of the most important numbers you'll see on that table. First, you've got the atomic number. This is the big one. It's just the number of protons. That's it. It's what makes hydrogen hydrogen and not something else. Then you have the mass number. That's just what it sounds like. You add up the protons and the neutrons in the nucleus, and that's your mass. Simple as that.
Okay, so we've met all the individual atoms, but honestly, the real magic, the stuff that creates the entire world as we know it, happens when these atoms start to interact with each other. This is where you go from just a list of ingredients to an actual recipe.
And that's the big question, isn't it? I mean, the world isn't just a bunch of separate piles of gold and oxygen and carbon. So how do these little atoms link up to create something as simple as a water molecule or as complex as a human being?
Well, the answer is something called a chemical reaction. And you know who the key players are? It's those electrons on the outside. A chemical reaction is basically just a process where atoms share, steal, or trade electrons. And this whole rearrangement creates new connections. We call them bonds. And those bonds form totally new substances with completely different properties.
And here's one of the most fundamental rules in the entire universe. You never lose anything. In a chemical reaction, you can't create or destroy matter. All you're doing is rearranging the atoms, kind of like taking apart a Lego castle and using the exact same bricks to build a spaceship. You always end up with the same pieces you started with.
Now, obviously, we're just scratching the surface here. Once you get these basics down, atoms, reactions, you unlock this entire world of chemistry. So just to give you a little taste of where this all leads, let's take a quick peek at one of the most common concepts out there, acids and bases.
What's so cool about this is that even something that sounds simple, like what an acid is, can be defined in a few different ways. You can talk about what it does in water. You can define it by whether it's giving away a proton or taking one. Or you can define it by how it interacts with, you guessed it, those all-important electron pairs. It all connects back.
And really, that's the whole story. From the mind-boggling emptiness of a single atom to the elegant dance of electrons that creates everything you can see and touch, these are the fundamental rules that run our world. So the next time you look around, just remember, you're seeing a universe of tiny building blocks, constantly being rearranged. The only real question is, what do we want to build next?